Let's take a look at question 22.30. Identify the reagents that you would use to produce each of the following compounds using a Claisen condensation. So Claisen condensation, and when I think Claisen condensation, obviously I think of beta keto esters. Beta keto esters. So here's my ester group over here. I have an ethyl ester. So going from here, I have my alpha carbon after the ester carbonyl carbon. I have my alpha carbon and then my beta carbon. So I have a beta on my beta carbon. There's a ketone, so it's a beta keto ester. So I think the easiest way to solve these problems, you can do them very quickly if you just do a quick retrosynthetic analysis. So what you're going to want to do is you want to break the bond between the alpha and the beta carbon. And let's see what happens when you do that. So let's break that apart and let's see what we have. So let's just leave that part as it is, and then the other part will be this ethyl ester. So we know that we need to treat this, we need to react this with another ester, and we know that we have, or we can obviously see that we have an ethyl ester, and we don't want to change the identity of our ester, so our other compound is going to have an ethyl ester. And what's interesting about this ethyl ester right here is that it has no alpha protons. No alpha protons. So this is a crossed Claisen condensation, and we're going to have to use a directed Claisen condensation reaction to get this reaction to work. So the way that we would do that, the way we would write this out, is we would start with our starting material, and we would treat that with a strong base, a very strong base like LDA, so that we get an irreversible reaction. LDA, and then the second step will be to add in our ester, our other ester. Adding in our ester. And the third step in a Claisen condensation reaction is always treating with aqueous acid. And that will give us our product. And you can look up the mechanism for that, or for this reaction. And we went over it in class, but if you think about these things retrosynthetically, you can solve them really quickly. So let's take a look at part E. Here's another one. This one looks a little bit funky because it's got this cyclic ester here. So this cyclic ester, you might remember that a cyclic ester is called a lactone, and we don't really need to know that, but it's just kind of a fun word to say, I guess. Anyhow, I'll erase that. So we still have a beta keto ester. You guys see that right away. It's a beta keto ester. This is our ester here with our, this is the carbonyl carbon on our ester. We have our oxygen here and our other oxygen on top. And so this is our alpha carbon and this is our beta carbon. So if we do a quick retrosynthetic analysis here, so if we do a quick retrosynthetic analysis, oops, did I use the right color pen? Sorry, here we go. If I do a quick retrosynthetic analysis here, I'm going to end up with this, and then I'm going to have my ester, put my oxygen here, like this. So this is going to be a crossed Claisen condensation as well. And in order to choose what extra functionality we're going to put on this molecule, it's not really important in this case because we don't really have to worry about transesterification. And we're going to use a strong base anyway. So let's just use a methyl ester for this one. So the way we would do this is we would take our ester, so we're going to start with our ester, and we would treat that with a very strong base, LDA. Oops, LDA. And what happens, I'll just draw the intermediate out here. When you draw your intermediate, this reaction is irreversible. You formed nothing but this enolate because LDA is such a strong base. And then you're going to treat that with your ester. So you're going to put that in there. So this would be step 2. Step 2. And the Claisen condensation is always followed by aqueous acidic workup. Okay? And you could draw out the arrows for this if you felt so inclined. You're just, woo, you go up here, oops, attack the carbonyl, and you could finish the whole thing. Anyhow, and you'll see that you get the right product. So that's why I mentioned in class, and I said, you know, one of the best ways to attack these problems is just to think of them in terms of a retrosynthesis and then go from there. So I hope this helps with solving Claisen condensations or crossed Claisen condensations, and there will definitely be a question like this on the quiz.